Bracket 7, Pythagorean Theorem, and Volume. For the first time, we're really going to need our formula card for this one, but I'd rather just memorize because I'm smart. Also, we're going to use a lot of calculator. That's why I'm sharing my whole screen. Now let's talk about the volume formula for each of the major players. We have a cylinder, which is V equals pi r squared h. We have the cone, which is literally the same exact thing, except there's a third in front of it. What that means is if you have a cylinder and a cone that share all the same measurements, the cone is literally 1/3 of the volume, or the cylinder is literally 3 times bigger. Literally, as long as all the measurements are the same. Sphere is V equals 4/3 pi r cubed. We don't worry about h for sphere. 4/3 pi r cubed. And the rectangular prism is the easiest of them all. Length times width times height. The rectangular prism is not on the formula card for the PSSAs. The other three are. So if you're like, oh man, I'm super worried that I'm going to not remember those, well, you don't have to. They're on the formula card. But memorize them because it's easy. No. You just have to remember that cone and cylinder are the same. It's just cone is 1/3 of a cylinder. That's part of it. And then you're just going to have to memorize the sphere all on your lonesome. Find the volume of each. Use appropriate units. All right, so I need to find the volume of this here cone. So I'm going to write out V equals 1/3 pi r squared h. I'm going to label what I know. 5 is the radius. 9 is the height. So I could just plug stuff in. V equals 1/3 pi radius, which is 5, squared times height, which is 9. Now I'm going to whip out my calculator here. Let's move the calculator to the left. To the left, moving it to the left. I type out 1/3 by doing parentheses 1 divided by 3. Pi is the second caret button. 5 is 5 squared, and then we have times 9. Hit enter, and there you have it. I don't remember if I said round it, but this is 235.6, so 235.6. One of the things that I said is to use appropriate units. Volume is measured in cubic units, so this is going to say inches cubed. Volume is measured in cubic units, so inches cubed, feet cubed, and the next one centimeters cubed. Area is square feet, square inches, square unit. All right. You are a sphere, a regular sphere. You are a regular sphere. V equals 4/3 pi r cubed. Now you have to be careful. See that 11.9? That's not the radius. That's the diameter. We want the radius, which means you take that number and you divide it by 2, and that'll get you 6.95. No, 5.95, 5.95, 5.95, 5.95. So whenever you're given the diameter, divide it by 2. Okay? Volume equals 4/3 pi 5.95 cubed. All right, let's bring back our old calculator. I'm going to do parentheses 4 divided by 3, close parentheses, times pi, parentheses 5.95. The way you type out cubed in your calculator, you can either hit caret 3 or Math 3 will do it. 882.3 centimeters cubed. This is volume, so it's measured in centimeters cubed. Oh. You might be able to hear my kids screaming. Work backwards to find the missing side for each. Ooh, these are much worse. All right. Volume. All right, so we have a cone, and it's telling me that volume is 5,361.65 centimeters cubed. So I'm going to write out the formula for a cone, which is 1/3 pi r squared h. Now I have to find h, which means I'm working backwards. So I'm going to plug that in for v. 5,361.65 equals 1/3 pi. I'm given r. 16 is my radius, so r squared is 16 squared h. Usually when we do these problems, the work backwards problems, you could do some math on the right side of the equal sign. And when I say usually, I mean every time. Every single time we do one of these, find the missing side. If you're given the volume problems, you can do some math on the right side first. So I can do 1/3. 1 divided by 3 pi is second, caret 16. Oh, 6. Can I type it? 16 squared. Is it squared? Yep. Enter. Now, that number is 268.1, we'll say, h. That's going to equal 5,361.65. Is h all by itself? No. What's in the way? This 268.1 is being multiplied to h. So I'm going to divide both sides by 268.1. Divide both sides by 268.1. Oh, 0.1. Okay, that crosses out. And so I can do 5,361.65 divided by 268.1. And I get 1999.8 or 0.8, 19.998, which rounds up to 20. Now, what's my height? 20 centimeters cubed? Nope. Height is just centimeters. Remember, volume is measured in centimeters cubed. But a regular old height is going to be regular old centimeters. Let's do it again. This time I have to find r. What is this? This is a cylinder. So let me write out v equals pi r squared h. I have to find r. I know the height. I know the volume. So why don't I write all that stuff in? I'm going to rewrite 2121.7. I'm going to change v into that. Pi is still pi. R is still r squared. And h is 21. What I said in the previous problem, that when I give you the volume and I'm working backwards, I can always do some type of math on the right. Just because they're not next to each other doesn't mean you can't do it. That's 21 pi. So I'm going to find out what 21 pi is. I can multiply those together. 21 pi. And I get 65.97. So I'll write all that. 65.97. That became that. R squared still drops down. That's going to equal 2121.7. Is R all by itself? No. I'm going to divide both sides by 65.97. Divide both sides by 65.97. 2121.7 divided by 65.97. 32.16 equals R squared. Now here's the tricky part. Is R all by itself? No. Squared is there. How do I undo a square? Square root. Now, if we had a regular old problem, we would attach a plus or minus sign to this. But we're not attaching a plus or minus sign because this is a real world example and you can't have positive or negative length. So I'm just going to do the square root by hitting second, and then the x squared button gives me the square root button. 32.16, enter, is 5.67, so R is going to equal positive 5.67, and that is regular old feet. So the radius is 5.67 feet. Remember, usually when I have to take the square root of both sides to solve an equation, I attach a positive or negative symbol or a plus or minus symbol. But in this case, I don't, because real world problems don't have negative lengths. And that's going to come into play a lot in this packet. On a golf course, the hole is 120 yards north of a tee and 70 yards west. How long must the ball go if he aims for the tee in one shot? He or she. So I have a right triangle, and my job is to find the diagonal distance. So when you are trying to find the missing side of a right triangle, you use Pythagorean Theorem, which is a squared plus b squared equals c squared. Doesn't matter which one you call a or b, as long as you call the longest side, which is called the hypotenuse, c. You're a leg, I'll call you A. You're a leg, I'll call you B. And the hypotenuse, the longest side, is C. So I called A 70, so 70 squared. I called B 120, so 120 squared. And that's going to equal C squared. 70 squared is 4,900. 120 squared is 144. Hundo, and that's going to equal C squared. Is C all by itself? No, but look at that. I have two numbers on the left that I could just add right up. Ooh. That becomes 100 and I don't know what that becomes. Let's use our calculator. 4900 plus 1400 equals, I missed an O. 4900 plus 14400 is 193. Is C all by itself? No. What's in the way? The squared. How do I undo a square? Square root it, of course. Usually when we take the square root of both sides to solve an equation, we attach a positive or negative symbol. But since this is Pythagorean Theorem and it only deals with length, you can have a negative length. So second, square root 19300. This is an irrational number because the number is an ugly, terrible number. When you take the square root of a number and it's terrible, it's irrational. 138.9 yards. Okay. All right, so this is what a PSSA formula sheet usually looks like for math. We haven't really needed it, but we could have used it a few times. I mean, you've got your exponential properties. So, you know, when two bases are multiplied together, add the exponents. Exponent to an exponent, multiply the exponents. When you have a guy living upstairs and a guy living downstairs, subtract exponents. Negative exponents, move it downstairs. We've talked about that ad nauseum. There's the slope formula in case you forget. There's slope-intercept form in case you forget. But now we're really using these guys. So if you ever forget your formulas, they're found on the formula card. So there's Pythagorean Theorem. There's the sphere. There's the cylinder. There's the cone. It's all there. I have mine memorized. We don't have rectangular prism on here, but that's okay. We don't really need it. At least I don't think we need it. Could be wrong. So let's start this packet. We've got another 20-minuter, and most of these have to do with finding the volume or Pythagorean theorem. So, what is the volume of this sphere? Use 3.14 for pi. Now, usually I use the pi button for pi, but this is telling me to use 3.14, so that's what I'm going to do. This is a sphere, so V equals 4/3 pi r cubed. What's my r? Well, that's my diameter. So my r is going to be half of that, which is 6. So that's my diameter. Divide that by 2, and you get your radius. So my volume is going to be 4/3 pi r, which is 6. That's supposed to be a parentheses, and it looks terrible. Cubed. Let's bring up my calculator. 4/3. They said instead of pi, use 3.14. Fine. Instead of pi, 3.14. 6 cubed. 6. Math 3 gets me cubed, or you can do the little caret thing right here. Math 3 works just fine. What if you use pi? Then you'll get like 904.33 or something like that. Doesn't make too much of a difference. Doesn't make too much of a difference. I would just rather use pi. Find the length of the missing side of the right triangle drawn. All right. Well, this requires, since it's a right triangle, this requires Pythagorean theorem. So a squared plus b squared equals c squared. It doesn't matter which one you call a or b as long as the longest side is c. So I'll call the missing one a and I'll call b 15. So a squared plus 15 squared is going to equal 25 squared. Okay? A squared plus 225 is going to equal 25 squared, which is 625. I have that memorized. Is A all by itself? No. What's in the way? I have a 225 that I could subtract from both sides. Cross it out. And A squared is going to equal, that becomes 400. Is A all by itself? Now, no. So I have to square root both sides. Now, usually when I square root both sides to solve an equation, I attach a positive or negative symbol, but I don't here because this is Pythagorean theorem and you can't have negative lengths. So A is not going to equal positive or negative 20. A is just going to be 20, and it's going to be 20 yards. I don't need a calculator for this because the numbers are friendly enough. The figure shows the ramp to a loading dock at Mr. Ferguson's store to the nearest foot. What is the length of the side R of the ramp? Why don't I do that over here to the right? To the right. This is a right triangle, so a squared plus b squared is going to equal c squared. I'll call you C. Doesn't matter which one you call A or B as long as the longest side is C. So the hypotenuse is C and these legs are A and B. So instead of A, I'm going to write out R for ramp, I guess. R squared plus B is now 8 8 squared, and c is now 15. Just like in the last problem, I could square some numbers, so I'm going to do just that. 8 squared becomes 64. 15 squared becomes 225. And then r squared never changed. Is r all by itself? Nope. I have a squared and I have a 64, so I'm going to subtract 64 first. So r squared is going to equal 225 minus 64. That's going to be 161. Is r all by itself? No. What's in the way? Squared. So what do? Square root it. Now, usually when you square root both sides to solve an equation, you attach a positive or negative symbol. But the answer can't be positive or negative because we're dealing with a length here. So second x squared gets me my square root button. 161, enter. Second x squared, 161, enter. 12.68. So 12.6 blah, blah, blah is going to round up to 13. I dabbed on that. Dorian is planting a garden in the corner of her yard. 2 legs of the garden are formed by a fence and make a right angle. Their lengths are 6 and 8. Dorian needs to buy a border for the hypotenuse of the triangle. What length does she need? All right, well, it tells me right here that I have a right triangle, so I'm going to draw that up here. Okay. It says that the legs are 6 and 8. Remember, legs is just fancy talk for the smaller sides. We need the hypotenuse, which is just fancy talk for the longest side. So I'm using a squared plus b squared equals c squared. It doesn't matter which one you call a or b, as long as the longest side is c. So I'll call a 6 and I'll call b 8. All right. So a is 6, 6 squared, plus b is 8, 8 squared equals c squared. 6 squared is 36. 8 squared is 64. That equals c squared. Ah, how nice. 36 plus 64 is a hundo. Is c all by itself? No. What's in the way? Squared. How do we get rid of squared? Square root it, of course. Now, normally, when we square root both sides of an equation to solve, we attach a positive or negative symbol. But we don't here because this is a real-life example, and you can't have negative lengths. So I'm just going to get a 10. 10 what? 10 feet? 10 feet. A large can of paint has a diameter of 20. I don't care about that. Hold on. I'm going to just stop you right there. I don't care about the 20. I care about the radius being 10. So let's just stop right there. Which expression equals the volume of this can? Oh, so I don't actually even have to do it. All I have to do is say this is a can, so it's going to be volume is pi times the radius squared times the height. So it's going to be pi times 10 squared times 25. Pretty easy. Pretty easy. No calculator necessary. No calculator necessitar. A waste paper basket has a diameter of 12 inches. Well, I don't care about that. I care about the radius being half of it, which is 6. Height is 18. Great. Which expression equals the volume of the weight? This is the exact same problem with different numbers. The volume is going to be pi r squared h. So the volume is going to be pi 6 squared 18 which is A. Kind of silly. Kind of silly that we have the same exact problem one after another. This diagram shows that the Pythagorean theorem is true for a triangle with sides of 5, 12, and 13. Which expression shows that the square of the hypotenuse has an area of 13 squared? The square of the hypotenuse has an area of 13 squared. Looks like it should just be the square root of 5 squared plus 12 squared, but that doesn't show up on any of them, so I'm going to be cute here. It's basically saying, hey, which one of these is 13 squared? So I'm not sure what this question is asking. It's just really weird. So this is how I'm going to approach it. 13 squared is 169. I'm going to see which of these gives us 169. Okay? That's what I'm going to do. Parentheses. Half is 0.5, so I'm just going to put 0.5 times 5 times 12, close parentheses, plus 7 squared is 79, so it's not U. Half times 5 times 12 plus 7 is going to be smaller than that, so it's not U. 4 times half, which is 0.5, times 5 times 12, close parentheses, plus 7 is 127, so it's not U, which means it has to be D. And I think what it's doing, I'm not sure what it's doing, but it's D. 4 half 5 times 2. I think what it's doing. Oh, you know what? I see what it's doing. I just didn't notice the fact that this is a square living inside of 4 triangles. This is a triangle, which has an area of 4 times a half times 5 times 12. So 4 of those is 4 triangles plus a 7 squared. Yeah, it's a dumb problem. I don't like it. But I guess I don't know. It's a problem you could run into, and I just kind of did a cheap way of doing it. The sphere below has a radius of 8 centimeters. What is the volume of the sphere? Use 3.14 for pi. All right, so V equals pi. Oh, this is a sphere, so 4/3 pi r cubed. V equals 4/3 pi. This is my radius, 8 cubed. So 4 divided by 3 is 4/3 times pi times 8 cubed is math 3, or you can do the caret thing. Oh, you know what? I wasn't supposed to use cube or pi. I was supposed to use 3.14. That's annoying. All right. So let's try it again. 4/3 times 3.14 times 8 to the third is math 3. See how close it is? 2,143.6 centimeters cubed. A line segment AB is located at 3,114.6. This is a tough problem. It is. This is what I would do. Find a coordinate plane somewhere else on your test or make your own coordinate plane. And that's exactly what I'm going to do. I'm going to make my own coordinate plane. These are both positive, positive, and positive, positive. So I only care about the quadrant 1. I need to go up to 6. 1, 2, 3, 4, 5, 6. And I need to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. One of my dots is 3, 1. So right 3 up 1 gives me a dot right there. Another dot is 14, 6. So right 14 up 6 gives me a dot right here. I'm supposed to find the diagonal distance. What I'm going to do is turn this guy into a right triangle. How long is the right triangle? Well, it starts at 3 and goes all the way over to 14, which is going to be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11. This guy started down here at 1 and goes up to 6, which is 5. Okay, now it's harder to count this way, but 1, 2, 3, 4, 5. I need to find C. So this is Pythagorean Theorem. A squared plus B squared equals C squared. It doesn't matter which one you call A or B as long as the longest side is C. So I have 11 squared plus 5 squared equals C squared. 11 is 21, and 5 squared is 25. That equals C squared. Add those two numbers and you get 146. Is C all by itself? No. What's in the way? Squared. How do I get rid of squared? Square root. Now, normally, when I square root both sides, I have to attach a positive or negative symbol. Well, not here, friend, because this is a length. And with length, we don't have negative length. It's not possible. So the square root of 140, you know what? That right there would be the best calculator ever. Beep, boop, bop. It's my face. Ah, ha, 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 ha. The square root of 146. Let's try that again. The square root of, oh my goodness, the square root of a, clear everything. The square root of 146 is going to be a little over 12. And approximate means about. Awful. Awful gross. Brian sees this tent in a catalog. He is 6'2" tall. And he wants to find out how he can fit in the, can he? All right. Well, here. Why don't I do this? Why don't I turn that into a right triangle where the hypotenuse is 10. Ooh, this leg is 9. So this guy needs to be bigger than 6'2", whatever 6'2" looks like. So, oh, and I don't even have to do that. It's just asking for what the height of the 10 is. Well, that's much easier. So I have to use a squared plus b squared equals c squared. I'll call you C, I'll call you A, and I'll call you B. So 9 squared plus b squared equals 10 squared. Was that 18 or 16? I think that's... I think that's 16. So I have to change it. It looked like 16. Or 18. So it's actually 8. 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 All right. Sorry. 8 squared is 64. B squared is B squared. 10 squared is a hundo. Is B all by itself? No. What's in the way? 64. Subtract it. b squared is going to equal 36. Is b all by itself? No. What's in the way? Squared. How do we get rid of a squared? Square root it. Now, usually when we square root both sides of an equation to solve it, we attach a positive or negative symbol. I'm not going to do that here, friend, because there's no such thing as a negative height. And I can do the square root of 36, baby. It's 6, which means this young bull's too tall. Poor Kevin, was it? Brian. I'm so bored, I wish Brian was here. Hey, guys. Brian. It's my favorite Vine. Look it up. I'm so bored. I wish Brian was here. Hey, guys. Brian. Tina is flying a kite. Her friend Grace is standing directly underneath the kite. How far above ground is the kite? Pythagorean Theorem. A squared plus, A squared plus B squared equals C squared. It doesn't matter which one you call A or B as long as the longest side is C. So I have 10 squared plus B squared is going to equal 50 squared. 10 squared is a hundo. 50 squared is 2,500. Is B all by itself? No. What's in the way? 100n squared, but let's get rid of the 100 first. Always get rid of the guy that's floating around first. B squared equals 2,400. Is B all by itself? No. What's in the way? Squared. How do we get rid of a squared? Square root it. Usually when we square root both sides to solve an equation, we attach a positive or negative symbol, but we're not going to here because this is a length, and you can't say length is negative. So I'm going to do the square root of 2,400. That will give me 48.98, which is awfully close to 49. What is the volume of this cone? Oh, let's find out. V equals 1/3 pi r squared h. V equals 1/3 3.14, because that's what they want us to use. R. What's R? Oh, just regular old 3. Nothing fancy there. What's H? Regular old 7. Nothing fancy there. So it's going to be 3 squared times H, which is 7. Calculator time. It's calculator time. 1 divided by 3 in parentheses gives me the fraction. Times 3.1415926 times, oh, I forgot something. 3 squared. Whoo! That was a close one. 3 squared 7. 69.94. 65.94. One more. One more to go. And we're done. Done this packet. A rectangular garden measures 30 feet, 8 inches wide. And a diagonal path cuts across the garden. All right. Here's issue number 1. 6 inches is half of a foot. So I'm going to do 40.5. 8 inches is 2/3 of a foot. So I'm going to do 30. Wait, no. I remember this problem. I'm being careless. I'm being dumb. Sharif walks down the diagonal and once around the garden. Approximately how far will he walk? Approximately? Oh, that's easy. If it's approximately, I don't care about these 6 inches. I don't care about these 8 inches. If it's approximately, I'm going to keep 30 and 40. Approximately means about estimate. So he goes down this diagonal, which I'm going to call C because that's the longest side of a right triangle here. And then I have a little bit more to do. So it was 30 and 40, and my longest side is C. So I have A squared plus B squared equals C squared. I have 30 and 40, and my longest side is C. So 30 squared plus 40 squared equals, I don't know, squared. That's 900. That's 1600. That equals C squared. 900 plus 1600 is 2500. That equals C squared. Is C all by itself? No. What's in the way? A squared. How do we get rid of a squared? A square root. Now, usually when we square root both sides of an equation to solve, we attach a positive or negative symbol, but we don't here because length can't be negative. So this is just going to be 50. C is 50. So let's go back up and clear this out a bit and reread the problem. He walks down the diagonal and once around the garden. So 50 plus 40 plus 30 plus 40 plus 30. 50 plus 40 plus 30 plus 40 plus 30 is 192. Where did I get that 2 from? It should be 190. 50 plus 40 plus 30 plus 40 plus 30 is 192. Okay? So my answer is 190 feet. And my explanation is that I rounded it to 30 and 40. I used Pythagorean Theorem to find the diagonal. And I added up the diagonal on all 4 sides. That's it. Wow, that was a doozy. That was tough. But you guys did it, and I believed every second that you could. Okay, well, that's it for me. Bye!